Fifth grade into math, lesson 12.3, represent and interpret measurement data in line plot. I can use a line plot to display data in fractional measurement and use the line plot to solve problems. Step it out. Number 1, students measure different amounts of water into their beakers for an experiment. If the total amount of water is redistributed equally, how much water will be in each beaker? Complete the line plot by recording the data for the beakers. The first 2 amounts have been recorded. Okay, so they already did the 1/4. So they already did this one, so I'm going to mark it off, and then they already did the 1 1/4. I put a very simple line through it so that I can still see it and then know what I still have left. So then they have 1/2. Then they have 3/4. Then they have how many 1/4? 3. So I need to put 3 more X's above the one they already have. Then they have 1 1/2. Then they have another 1/4. Then they have a 3/4. And then they have a 1/4. And then they have a 1 3/4. So how many cups of water are in the beakers that contain 1/4 cup? So basically, how many X's did I draw there? And they already have. So 1, 2, 3, 4, 5, 6, right? So I'm going to take 6 times 1/4. So that also equals 6/1, which equals 6/4, which equals what? 1 2/4, which also equals 1 1/2. And what's my label? Cups. What is the total number of cups of water? So they want to know for the whole entire chart. Okay, so for that 1 1/4, it would be what? 1 1/2 plus 1/2 plus what's 3/4 plus 3/4? 6/4, which we said 6/4 is what? 1 1/2 plus 1 1/4 plus 1 1/2 plus 1 3/4. Okay, so some of these we can group together real quick to make it a little easier, right? So we could go ahead and group this together. And then these 2 together, right? Okay, so what is 1 1/2 plus half? So 2 plus, what's 1 1/2 plus 1 1/2? 3 plus, so then we could also do these 2 together, right? What's 1 1/4 plus 1 3/4? It'd be 2 4/4, which is 3. So our total would be 2 plus 3 plus 3 is 8. So 8 cups is our total for the whole chart. How many beakers are there? So how many beakers, how many X's do we have on that chart? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 beakers. Redistribute the water equally among all the beakers. How many cups of water will be in each beaker? So what would we do? What's our total? Not 8 divided. Yes, what's our total? 8. So we have 8 cups of water, and we're dividing it amongst how many beakers? Divided by 12. And we've also learned when you do that, you can just write it as 8/12 because that division sign also could be a fraction bar, right? The fraction bar can also be division. So what is 8/12? Because that's not simplified. 2/3 because 4 goes into both. So 2/3 of a cup. So on letter E, we also found the average, right? Okay. Stepping out number 2, Lamar divided 3 2-pound boxes of cherries into smaller boxes. The first box was divided into boxes weighing 1/8 of a pound each. The second box is divided into boxes weighing 1/4 of a pound each. The third box is divided into boxes weighing half a pound each. Find the number of 1/8, 1/4, and half-pound cherry boxes, then graph the results on a plot line. Letter A. Use division to find the number of 1/8, 1/4, and 1/2 boxes that were made from 3 original 2-pound boxes of cherries. So they went ahead and said the 2 pounds was divided by 1/8, so that would become 2/1 times what? 8/1, which becomes 16. 16/1, which becomes 16, right? Okay. The next one, they took a 2-pound box and then made it into 1/4 pound little boxes, right? Okay, so 2/1 times 4/1 becomes 8/1, which is also 8. Then they took the other 2-pound box and made it into smaller things of half-pound. So that becomes 2/1 times 2/1, which becomes 4. So now they want us to make a line plot and include a title to describe what you are counting, then plot an X for each 1/8, 1/4, and half-pound cherry box. So we're going to kind of do like what, set up a line plot like the front side had on it, okay? Okay, so maybe our title might be number of cherry boxes by weight. Okay, and then usually when you say that, do we have a specific measurement? What's it in? In pounds, right? So we're going to go ahead and say pounds. Okay, then we're going to have our line. Okay, and then we have 1/8. We have 1/4. And we have 1/2. So we went smallest to largest with our weights, right? How many X's do we need for 1/8? 16. So what I'm going to do is, I can't really go up 16 high, right? So just above that, I'm going to put 16 X's. Okay, and then 1/4, how many X's? Okay, what did we come up with for 1/8 or 1/4? 8. Okay, and then how about for 1/2? 4. Okay, so how many more 1/8-pound cherry boxes are there than a half-pound cherry boxes? So we drew 16 X's for 1/8, and we drew 4 for 1/2. So what is that? So 16 minus 4 equals 12. So 12 boxes. Check for understanding. Number 1, Charles poured different amounts of milk into some bowls. Show the amounts on the line plot. So he has a 1/8, he has a 1/4, a 1/2, a 1/4, a 1/8, and then 3 1/4. So I have a total of 1, 2, 3, 4, 5, 6, 7, 8 X's. And I have 1, 2, 3, 4, 5, 6, 7, 8. So did I get everything plotted on my line plot? Okay. So what is the total amount of milk that Charles poured? So we have to add all those up, right? Okay. So how many X's are on 1/8? 2 times 1/8. So that would be 2/1. So that would be 2/8 equals what? Actually, let's do it this way, so we don't take up so much room. So 1/8 plus 1/8 is what? 2/8 plus 1/4 plus 1/4. If we did that 5 times, what would that be? 5/4 plus 1/2, right? So what's the common denominator, guys? 8. So 2/8 plus, what's 5/4 with 8? 10/8 plus 4/8. So we know 8 is our denominator. 2 plus 10 plus 4 is 16. So then that also equals, so 2 pints is our labels up here, right? If Charles redistributed the milk equally among the bowls, how much milk would he pour into each bowl? So what's our total amount? The 2 pints. So 2 divided by how many x's do we have? 8. So that also can be written as 2/8, right? Which equals, so 1/4 of a pint. Number 4, or on your own, number 4, a scientist records the weight of her mineral specimen. Make a line plot to display the data. Okay, so we're going to have our label, which mineral specimen weight, and then in ounces. Okay, and then of course we have our number line, or our line plot. Okay, and then we have 0. Then what are we going to go in increments of, guys? 1/4, right? Okay, so here's 1/4. Then we have half, and then we have 3/4, and then 1, and then 1 and 1/4, 1 and 1/2, and then 1 and 3/4, and then 2, right? Okay, so half, I have 2, right? 1, I have 1. Half, I need another 1. 1/4, 1 1/2, 1 1/2, 1 again, and 1 and 1/4. So I should have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Okay, so what is the total weight of the mineral specimen? So 1/4, how many is there? So 1/4 plus 1/2 plus 1/2 plus 1/2 is 3 halves, right? Plus 1 plus 1 is 2, plus 1 and 1/4, plus 1 1/2 plus 1 1/2 is 3. Okay, so I could go ahead and group a couple of things together, right? I could put this 2 and this 3 together, right? I could put this 1/4 and this 1 and 1/4 together. So what is 1/4 plus 1 1/4?
1 2/4.
1 2/4, which is 1 1/2. Plus, I can make this 3 1/2 into what? Or 3 halves into 1 1/2, right? Plus 5. So what is 1 1/2 plus 1 1/2? 3. Plus 5 is, so 8 ounces, right? Okay. Then what is the combined weight of the 1/2 ounce and the 1 1/2 ounce specimen? So we had 3